So hey guys, I am Suchetan and I am electronics undergraduate with Pilani. So in this sort of a lecture, which is also my first video on this channel, I will be focusing on river man problems or the river boat problems. So essentially this whole fuss that is created about this concept is 6 concepts. That's it. If you can learn these 6, then you are a master at this. So first one is the drift. What is drift? Now let's just say you were rowing the boat in this y direction and you intended to reach point B, but you reached point C. So the distance between this point B and point C is known as drift. And next is the width of the river, which is quite obvious. You know what is width of the river. Velocity of boat in still water. Now this is essentially the speed with which you can row the boat. Now if they tell you that the velocity of man with which he can swim in still water, this is also the same as velocity of boat in still water. It is with which you can move the boat, the speed with which you can move the boat. So next is the velocity of river, which is quite obvious, the speed with which the river is flowing. Okay, so now let's move on to learning the concept. So when I say learn the concept, what I essentially mean is these two statements. That's it. That is, movement along the x direction depends only on the x velocities, and movement along the y direction depends only on the y velocities. So this whole space is basically divided into two axes. We all know that, x and y. So let's just solve a small problem and that will clear out everything for you. Now if they say that the width of the river is 5 meters and velocity of boat is also given as 5 meter per second, and they also give that the velocity of river is 4 meter per second. Now they're asking you what is the time taken and what is the drift. So let's begin. Now the time taken is, as we all know, which is distance by speed. So the distance here will be width of the river, this width. So width. Now remember that this width is in y direction, okay? By distance by speed, and speed is velocity of boat. Now we also need to keep in mind that this also has to be taken only in the y direction. Okay, because the width is in y direction, the velocity also has to be taken in the y direction. So which is basically width is given as 5 meters divided by the velocity of boat, which is 5 meter per second, which is essentially 1 second. Now if they ask you to find the drift, so think about it. Drift is a thing that we've defined in x direction, right? So this is x. So drift is distance, which is equal to speed into time, which is equal to speed in the x direction, which is velocity of river. So velocity of river into the time has no direction, so it's just time. So velocity of river is given as 4 meter per second. So 4 meter per second into 1 second, which is 4 meters. Now this is drift. Now I have a small challenge for you. Just take a moment and think about it. Now if I say that this is the boat and we have given velocity of the boat in this direction, and this is making an angle theta with the y-axis. Now can you tell me, while finding the time, what will be the velocity of the boat you'll take? Take a moment, think about it, and then start playing the video. It will be width, that is in y direction, divided by the velocity of boat in the y direction. Now velocity of boat in the y direction is, in this case, is velocity of boat into cos theta. Can you think why is that? because when you do cos theta, you are essentially taking this component. That is, this is velocity of boat cos theta, and this is velocity of boat sin theta. You are ignoring this velocity of boat sin theta because that is a component in the x direction and you're taking width in the y direction. So that is why you take velocity of boat into cos theta. So the final answer is basically width divided by VB cos theta. Okay, so now let's focus on learning this shortest time concept. So now we have gone through this a million times. So which is time is equal to width of the river in the y direction divided by speed, which is velocity of boat in the y direction. Okay, so now if I ask you that what is the angle with which the boat has to move, like suppose let's say this is velocity of boat and this is y direction and this is theta. If I ask you that what should be the value of this angle theta for which a shortest time is taken, how will you answer it? So for shortest time, the this left hand side should be minimum. That means velocity of boat in the y direction should be maximum. But we know that the velocity of boat in the y direction is VB cos theta. So if this has to be maximum, that means cos theta has to be maximum, which means cos theta is equal to 1, which means theta is equal to 0 degrees. To cross a river in shortest time, travel, you need to put the velocity of boat in the same direction as y axis. So that these two are in the same direction and you get maximum push in the y direction. So that means the time will be minimized. So if they ask you that what is the shortest time and they give you that the velocity of boat is 5 meter per second and the width of the river is 5 meters, then the time will just be distance, which is 5 meters, and you're putting the whole of 5 meter per second in the y direction, so that will just be 5 meter per second, which is essentially 1 second. Okay, so now let's learn what is this concept of shortest path. So remember, in the beginning of the video I told you that the distance between the point where you intended to reach but the point you reached was drift. So shortest path basically means that this drift has to be zero, because if drift becomes zero, then you will reach along a straight path, which means it's shortest. So we know that the drift, which we calculated a little while ago, was velocity of boat in the x direction into the time taken. Now, if this has to be equal to zero, time cannot be zero because we have to cross the river. So this is not zero. So that means velocity of boat in the x direction has to be zero. But you cannot make velocity of boat in the x direction to be zero because there is a velocity of river which is pushing the boat in this direction. So what you need to do in this case is, if this is the boat, you need to move the boat you need to provide the velocity at an angle theta, this is y and this is x, at an angle theta such that velocity of boat sin theta should be equal to velocity of river. Can you think why I'm doing this? The main reason is that when you put the velocity in this direction, it will have two components. One is VB cos theta and one is VB sin theta. So there is a VB sin theta in the left direction and there is velocity of river in the right direction. So when these two cancel out, essentially the velocity of boat in x direction becomes zero. So that's why I'm telling you that you need to put the velocity of boat at an angle theta such that VB sin theta is equal to velocity of river. So this was drift. So the main idea of shortest path is VB sin theta should be equal to velocity of river. Just remember this for shortest path. You need not remember because you know the concept now, but yes. Now, there is a small example. It's a quite a tricky one, but I'm sure you'll be able to solve it. The question is, what is the time taken when the shortest path is followed? You need to give an expression for the time taken, and this should not contain theta. Without theta, you need to find one. Just pause the video for a few minutes and then try. Okay, so now I'll give you the example. I mean the solution. So we know that the time taken, I'll just change the color. We know that the time taken is given as width of the river in y direction divided by velocity of boat. I'll just write VB in y direction. So the two conditions given is shortest path is followed and the answer should not have theta. So when shortest path is followed, we know this happens, that velocity of boat sine theta is equal to velocity of river. So we know that VB sine theta is equal to VR. And velocity of boat in y direction in this case will be VB cos theta, right? So the time taken will be width divided by VB cos theta. This is the time taken, but they are asking without theta. So for that we have sine theta's expression here and we can figure it out. So from here sine theta will be equal to VR upon VB, and cos theta is equal to under root 1 minus sine square theta. Sine square theta. So if we plug this here, we get time is equal to width upon VB under root 1 minus VR upon VB the whole square. So this is the final answer. Okay, so that concludes the explanation part of this riverman and riverboat problems. There is one thing left, which is example problems that we will cover in another video. I'll probably solve 2-3 problems for you, and watch that and you will become very good at this. So let's finish this lecture, and thanks for watching. Please like, and if you have any comments or doubts, please put them in the comment box. I'd highly appreciate it. Thanks a lot. I'll see you again.